Let's add our handle resource sub-tree. Hello everyone, this is Ali Reza. Welcome to the Mentor Code Lab. In previous episode, we implemented the has resource sub-tree. This one will reduce the amount that we want from any resource inside the block entity. So to make it, we'll go back into our logic package. We say Java class and we say handle resource subtree. Now take note before I hit enter, I already renamed the previous class so that instead of fluid everywhere else I'm using resource, and I renamed this boolean to should use resource, and here use resource, because as we talked, now this tree can be used for fluid, energy, I don't know, any other resource type like gas or molten stuff or temperature. It's generic enough to handle all of that. So here we want to handle the resource. Again, using this as a temp, it's just extending the logic tree and it's a subtree. Okay. Now this guy again, I will use the copy paste because we will use it a lot. So here we want to make sure that we should use the resource or not, because if I take note, this is the very first thing we should check, and then the rest is actually happening from there. So we add a property, a blackboard, and then this guy needs to be renamed to resource amount supplier, copy it from there, paste it there, paste it here, and then we want another thing. Now this thing is an action node that says reduce resource. So here we want a supplier of, actually no, let me think about it. We don't need it here. It's a consumer, it's not a supplier actually. So consumer, now the consumer needs a T, okay, and this guy will have an integer, or actually a long, and we call this one resource reduction consumer. So let's move here. We want a resource reduction consumer, and because of that we want this guy to be another parameter here. Let's start from here. Should use resource, yes, that's the same method, and negated again is the same thing. Then has resource node, has resource, that's the same thing. Then look at here again, something that I did not rename. So this is resource amount supplier. Here we want to rename it to resource amount supplier. If it's not null and it's greater than 0, so we know that we have the amount, but here we need to change it because we don't need to check if it's 0. Okay, so if we say it's greater than or equal to this guy dot, oh, we need the amount, so we need a long reduction amount, and here I will say comma long reduction amount. So we send in the reduction amount. Now we want to have it as a param right after the use resource here. So here we want to say if it's greater or equal than reduction amount, then we want a sequence. That's correct. Then we want a not, and we want an action actually here. So an action node of type T, and we call it reduce resource action equals to new action node. Now this guy is asking for blackboard, so I will assign the blackboard because we didn't accept it, but the tree will have a blackboard. So in each case, we want the blackboard to be sent in, and here we sent in the blackboard. So this dot, actually, I don't need to do that this way. So here I just need to say this dot, although it's redundant in C#, but in Java it's a good practice to use this here. Okay, so we assigned the blackboard. Now I need to make sure that I did this change inside this guy every time that we are sending the blackboard. So instead of sharing a new blackboard, every time we are using the same blackboard, the same object in memory. So the blackboard from the tree is exactly the same blackboard that the nodes will use. So after the blackboard, what else do we want is actually a supplier. That's correct. So we say this goes into, now we want to open this one. At the very end, we will return success. We don't care if we did succeed on the block entity or not. The consumer, now we can say if, actually, yeah, we can fail here. So we say if the resource reduction consumer does not equal null, then we want to do things and at the end return success. Otherwise, we return failure. Return failure. Come on, find it. There we go. So now that we know that the consumer is not null, we say resource reduction consumer dot accept the reduction amount. And that's it basically, okay? And we return success there. So that's our action node. If you want to see how an action node is being added, that's it. The rest is actually familiar. So let's start from here. We are checking if we should use energy and we have energy. Then we say that this dot add child, what we want is the reduction action. Then we add the condition to the node for the not. Then for the root, that is the selector, we add the sequence first, then the not, and finally we add the root to the start node and we finish it. Funny, but this is the whole tree. This is this whole tree. So let's follow the logic. When we want to reduce any sort of resource, energy, fluid, gas, temperature, anything else, if we want to do the reduction, okay, or actually let's rename this guy to adjust resource supplier, okay, and here we rename it to adjust resource supplier, because the thing is that we may want to reduce something or increase something. So if we provide a negative number, it will work. If we provide, oh, this will be a problem here. Okay, let's do it in this way. We want to check if the reduction amount is greater than 0 or equal to 0, we don't care. And this, okay, let me break it into the second line, or the second condition. Now this condition is when the reduction amount is negative, okay? Means that we want to reduce, for example, 10 units of energy. So we will use minus 10, and all we want to check is that it's actually greater than or equal to 0 to this guy. This one, however, needs to be changed because this one is different. So we want to add things to the resource and we want to make sure that we didn't bypass the max amount. So here we want to have another supplier, and that is the max amount supplier, resource max amount supplier, and I will add it here. So we want to send in here. We want to make sure that this supplier is not null. So and this does not equal null and the rest. So here, no, we don't want that here. We want it here. So if the amount supplier does not equal to null and the rest, now here we want to make sure that we are smaller or equal to the max amount supplier minus the thing. So dot get, okay? If we want to, we can break it to multi-lines, move it a little bit indented. There is another way of doing it if we want to bypass that negative, and that is adding it here. So basically the amount that we have plus equal the one that we want to add should be smaller or equal to the maximum capacity if we are positive. If we are negative, all we are caring is that we are smaller than provided amount. We need another parenthesis and that's it. Okay, so now if we produce a positive number, means that we want to add a fluid to a tank, for example, then we check if the max amount is available. We make sure that the current amount is available, and then we check that the current amount plus the amount that we want to add is not exceeding the max amount capacity of the container. If we want to reduce fluid, then we will produce a negative number. Then we say the reduction amount or adjustment amount is a better name for this guy. Let's rename it to adjustment amount, and here too. So adjustment amount. So if the adjustment amount is negative, means that we want to reduce things. We just make sure that we have enough to reduce. And then finally, we are just adding an action node that calls our block entity and sends the adjustment amount back to block entity, so it will add or remove fluid from there. Okay, whoa, I could break it into two nodes. For example, add a resource and reduce resource or remove resource. I don't know what the name would be, but this is robust enough. It will handle both case scenarios, so you don't need to have two different nodes, one for increasing the energy, one for reducing the energy. I think that's it. So just by doing it, again, not only we covered these two, but also things, for example, like gas, temperature, molten fluids, or anything else. Can be electricity, I don't care. It can be my grandfather's car count. I don't care. The amount of a resource should be supplied by the block entity. The block entity is responsible of handling some sort of amount on a resource that it has. All I'm doing is just sending the amount and max capacity from block entity and then calling the block entity to adjust itself. I'm not going to add a mockup here because it's really not that complex. And by the way, here we don't have the aggregation. It's just the resource supplier. If we want to, yes, this is handle resource subtree, and it's again handle handle resource subtree. So should use, then we have the properties, the blackboard, then adjustment amount. So let's say that we want to have 10 units of energy being reduced or added. Remember, right now we are adding. If I make it negative, then we are reducing. Okay, so let's say that we want to reduce 10 units. Then the supplier for the amount is actually this. Let me copy it and then move it to the second line. The supplier for max amount will be energy max amount, for example. Okay, and then finally the just consumer. Why did I call it supplier? Anyway, it will be the same thing, but we say adjust energy, and I hope that's it. I'm not sure if this will work or not, but we will take a look at the real implementations later on. But long story short, this is how you will do it. If it's fluid, then just convert these three from energy to fluid. Or I'm not sure if we can use colons here. We should be able to use colons here, honestly. And let's say that instead of this dot properties, we have a block entity BE, and all we want here is saying BE dot blah. Although now it's yelling that, hey, initialize it. Okay, let's it be null. And now it says it doesn't have the get amount or anything else. Okay, so if you want, you can start trying it inside your block entities. Honestly, I think this should work to read the block entity from the property and then colon the method names. That should work. Anyways, that is for this episode. If we can't use it like this and we need to adjust parentheses here, then that consumer will be a little bit of a problem here, but I think it will work.
If you like these videos, please subscribe to the channel, hit the like button, and turn on that bell so that when I publish a new video, you will get informed. Have fun, everyone. Bye.